So here is what we are going to learn today. So the topic of the talk is VE tokens and their benefits. So at the outset, let me tell here that in this talk, we are not going to assume that you have any background whatsoever in blockchain. And VE tokens have to do a lot with blockchain. So we will start from scratch, explain conceptually what blockchain is, what its technological implementation is like, what are the advantages of this new type of technology. Once we have developed a deep understanding of the concepts behind blockchain, we will be in a position to understand how we can associate money, assets, and other financial topics with blockchain. And in the course of doing so, we will come across with concepts such as cryptocurrency, crypto tokens, and we will develop deeper understanding of each of them. And once we have a solid background built through first two sections of the talk, we will be fairly quick to understand what V tokens are all about and what are their benefits. So that's the plan outline as I have mentioned here. First, we'll look at all about blockchain. Then we'll see what could be possible connections between money, assets, blockchain. And finally, we will understand the V tokens. So let me start with the blockchain. So as I said, yes, this talk is about V tokens, but we will first start understand blockchain. Once we have clear idea about it, we will be able to go to V tokens. So here is the main idea. So let me give you a bunch of examples to really motivate the conceptual framework behind blockchain. So here is the first example. Think of a bunch of friends playing card games. After each round, depending upon the outcome of the game, each person receives certain points. I think if you have played this game, you would be able to connect with this really well. And after a certain number of rounds, you say the game to be finally ended. You note down which person or which player has received the highest points, and you declare that player to be the winner. So that's the basic construct of the game. The key thing that we want to highlight here is there is a need here to record the information. As we just saw, that after the end of the game, we need to decide the winner of the game based on who achieved the highest points. So, in order to track that information, we need to have some way of recording information after each round of the game. So, those who would have played this game, they will most likely be doing this traditional way of information recording in this specific game case. So if even if you have not played, nothing to worry. You will intuitively very quickly understand what this traditional way we are talking about. So you assign the responsibility of noting down points earned by each player to a single player. That player will keep a private notebook, and after each round, depending on what happens in the game, that player will note down what is the points earned by player one, player two, and so on. Uh, so what are let's think about the potential disadvantages of this method. So one definite disadvantage is that every player who is not recording will have to trust the person who is chosen to be the recording person, right? Uh, Apart from that, you would also recognize, or you can also think that yes, uh, if that person has wrong intentions or person is not honest who is recording this information, he or she has the freedom here to possibly tamper with the existing record to basically turn the game in favor of her or himself. So now comes the really the crux part of this whole talk. where we want to understand what could be an alternative way of this traditional way of recording this information. So here is the idea. You, instead of relying on one person, whoever is playing the game, everybody will keep his or her own notebook, and everyone after the end of each round will note down the points earned by every player. So after first round, player one will note down what happened in the game, player two will note down what happened in the game, player three will note down what happened in the game, and so on. After every round, this needs to be done. Another design criteria for this approach is that after every round, you need to have consensus among the records written by every player in this game. So, what I mean by that is, let's say after round three, person one has recorded uh, score earned by player three, let us say, to be 5 points. And person three, who is playing also playing this game, has recorded the same players, which means player three's points earned in that particular round to be, let's say, 10 points. Now, here there is a mismatch, right, between player one and player three's private records. So, with this approach, we will make sure that unless there is consensus, we will not move forward in the game. So, what are the clear advantages of this? So, definitely we can see here that since everybody is now noting down the record, there is no need to trust anyone. And also, since now there is no single person noting down, and on top of that, there is this requirement of additional consensus to be happening among all the private records, we will see that tampering is also not going to be possible with this approach. Why? Because let's say person number two, he or she tampers with a particular record. What will happen? At the time of matching or at the time of deciding whether consensus has been achieved, player two's record won't match with rest of the players, right? And that will break the consensus. And with the new approach, since we have applied this additional constraint of having to agree among player, having to generate agreement among players, this particular uh, tampering won't be carried forward. So that was the first example. Let us get some more feel around this new approach by taking another example. So think of a school grading system. So you have a class of students, there is a teacher. After every exam, he or she, the teacher, notes down all the students' grades achieved in that exam, right? And that's the traditional way of recording this grade related information. Uh, Let us look at, just like what we saw in previous example, what are the potential disadvantages of this. So obvious one is everyone else or every student has to trust the teacher about correctness of the grade being recorded. And also, if teacher has malintentions or he or she is biased towards or against some a group of students, then she will tamper with grades, right? So, and on top of that, there is one more disadvantage that if for whatever reason something happens to this centralized record that is that is being kept by teacher, then what will happen? The whole information will get lost, right? Uh, for whatever reason, if that in one piece of a notebook is lost, then there is absolutely no information remaining. Now, let's see the new way that we described just now. How will that work in this setting? So yeah, here the participants are what? All the students and also teacher. So in the new way, what we are going to do is, in addition to teacher recording all the grades, every student will also record entire class's grade, and everyone will keep the shared copies. So, what are the advantages we will get out of this? Definitely, the single point of failure issue that is gone, because even if one of the students' record is lost, then still we have rest of the class record to refer to. And of course, there is no need to develop any trust to on teacher here, right? And since there is this consensus enforcement requirement, the tampering will also not be possible, because if at all one of the student is, let's say, tempers with the grades, then his or her copy is not going to match with rest of the class, and that will enforce consensus to get broken, and that will sort of stop the system, right? Finally, let us look at one more example of recording bank transaction. So typically in a bank, what happens? There is a large data set that is kept, and it is with the bank, single ledger. All the customers will have to trust bank to correctly record all the transactions. And as we spoke for the other two examples, here also it is possible to tamper with the records. If bank certain employees of the bank have malintentions, biasness, then definitely the transaction recording is at risk. Now come the new way of recording information. What will that look like here? So here, instead of just the bank recording transactions in the new approach, we will have each and every customer of the bank noting down their transactions and everyone else's transaction. So everyone will keep the shared copy. As a result, there is no need to trust anyone. And also, the consensus enforcement will ensure that the tampering with the existing record is also not possible, because if anyone tampers, his or her copy will go out of consensus, and that will essentially stop the whole new system. So that was the, at a high level, conceptual understanding of the main idea behind blockchain. Now, let us see at the technological implementation level what is really blockchain all about. And before we go there, let's formally name things. So this specific new way that we have been talking about in all three examples, where we ensure every participant in the network notes down the entire ledger or entire information record and keeps the private copy with his or herself. This new way of recording information is called blockchain technology. And the actual information that is getting recorded is called blockchain. So, for example, in those three examples, the blockchains are, in the first example, blockchain is the game scorecard. Then in the second example, we had blockchain of school grades. Third example, where we saw bank transactions, there we will call blockchain of bank transactions. So, yeah, that is how blockchain at conceptual level is understood now. Here is the formal definition. Just this is just a recap of what we saw in those three examples. Three key aspects or special advantages, features, you can say, of this blockchain technology is that it produces tamper evident, tamper resistant, distributed digital ledger, right? We now understand each of this term very clearly, right? Why distributed? Because we have every user noting down the entire record. Tamper evident because of the consensus enforcement, and tamper resistant due to the very same reason. And it's a digital ledger. So that's the long and short of the blockchain. Now, we are going to deep dive into the technological aspect of the blockchain. So to go in that direction, let's ask this question. Where is this name coming from? Blockchain. Why this name, right? So it's a genesis of this name is from chain of blocks. So blockchain is equal to chain of blocks. So let's ask, what is this chain? What are these blocks? And where are these words coming from? Because so far what we have seen, we have just talked about this new way of recording information, right? Everyone noting down his or her private copy of the large database and having to enforce consensus after each transaction record and so on. We never came across this word called block or chain, right? So that's what we will now focus on. So let's revisit examples to get the main idea clear. So let's say that particular game of playing cards, there are now just three players playing that, Alice, Bob, and Carol. And this is how game is progressing. So after round one, Alice has earned 5 points, Bob 0, Carol 10. In round two, Alice earns 0, Bob earns 10, and Carol earns 5 points. And round three, Alice earns 15, Bob earns 20, and Carol earns 10 points. So that's the specific setting of the game where we are looking for only three players. Now, to understand really how this will be implemented in blockchain setting technologically, we have to develop some understanding about cryptography. So, this slide, we will focus on some preliminaries around that. In particular, let's understand what this term cryptographic hash function really means. Well, think of it like a magic blender. Okay. So what you have in blender, you input a bunch of fruits or a bunch of vegetables, out comes a soup or maybe a smoothie, right? So this hash function is like that blender. And it has this special property, your blender, that if you change even a little bit of your input, the blender will produce a completely different looking smoothie. So that's the conceptual understanding of this hash function. Now come to the reality. So in this particular thing, we will be operating in world of computers, and essentially at the technological level, it's a special formula. So cryptographic hash function is just a special formula. You can understand it for now that way. What it does is it takes any kind of data. It may be a sentence, could be a file, could be an image, anything, and it will turn it into a fixed size unique string. Okay. And again, some terminology. This output smoothie that is produced by this blender, in our mind, blender is that hash function, is called hash. So you put in a bunch of fruits, out comes smoothie. Smoothie is hash. Blender is cryptographic hash function, and the input is any data, any type of data. So with that much cryptography preliminaries out of the way, let's go back to our scorecard in the playing cards game. So this is just the same table that we saw earlier. Now, what we want to do next is really understand in blockchain technology, how will this scorecard be going to look like when we actually implement in a computer this particular scorecard. So what will happen is there will be something called as block. Each block will note down a particular record. So here a particular record is the points earned by all the players in the game in each round. So your first round's information will be stored in block one. So here is what we have written. Data for block one will be the points earned by all the players in round one. So just to go back, Alice's score is 5, Bob's score is 0, Carol's score is 10. So the data in block 1 will be A equal to 5, B equal to 0, C equal to 10. Now, in this new technological setting, there is this additional requirement that we note down previous block's hash. So hash is just output of the cryptography hash function, right? And since this is the very first block, right, corresponding to first transaction in this whole scorecard, it's called a genesis block, and there is no previous block for this block. Hence, the hash of the previous block will be 000. So now we concatenate both of this information, the data of the block, actual data, and hash of the previous block together. So 5010 comes from data, and this 40 comes from previous block hash. And finally, this entire block one's information is converted into a hash to that magic blender that we have understood hash as, right? So hash of this ABC along with the previous block's hash goes into the cryptographic hash function and produces this particular output. So for this talk, let us not worry about why this particular input's output looks like this. We will treat this particular thing 1AA 3B 4CD as something which is given to us. Okay, we will not worry why this particular output comes for this input. Okay, it is just given to us. So that was about block one, which recorded, remember, round one's information. Now let's go to block two. So here what we'll be doing, we will be noting down the points earned by each player in round two. So let's see what was round two score. So in round two, A was 0, B was 10, C was 5, right? So going to here, that's what data in block two will look like. And previous block for block two is going to be block one. And hash of that block is what we already have seen here. So we just bring this information piece here and concatenating these two pieces, we get this whole information piece as the concatenated input for block two. And finally, to represent the whole data of block two, we will convert this concatenated input into corresponding hash through the blender, magic blender called hash function, right? And let's assume this is given to us as we saw in case of block one. We are not worried about how this comes based on this, at least for this talk. So that was block two. So now you already see here there is some logical connection, right, getting built between consecutive blocks here. Why that is happening? So it is because of this requirement that in each block you are required to include the hash of the previous block, and that is what is creating this connection. Finally, let us see block three. So what will this be containing? This will be containing the information that was recorded in scorecard for round three. So let's go back. What was in round three? So A was 15, B was 20, C was 10 in round three. So that's what will constitute the data for block three. A is equal to 15, B equal to 20, C equal to 10. Now, what will be previous block for block three? It will be block two. And hash of previous block, we already have noted down here. That will flow in here. And concatenating the inherent data of block three with the previous block hash, we have this as the concatenated input, correct? And finally, to represent this entire information of block three, we will convert the concatenated input into a hash. And let's assume this is given to us. So now you see clearly there is a chain being built because of this logical connection happening across subsequent blocks, right? So that's what we are explaining in the next slide here. As we saw, each block's hash depends on block's own data and also on hash of the previous block, right? So block two's hash was dependent on block one's hash. Same way, block three's hash is dependent on block two's hash, and so on. And this creates logically connected chain of blocks, hence the name blockchain. So now we have established where this name blockchain is coming from. It's chain of blocks. And here we have shown a schematic diagram for that. Now to solidify even further this idea of blocks and hashes and chains getting created, let's look at the second example that we saw earlier, right? At conceptual level, how at the technologically implementation level, how will the details look like? So here is the grade card of a particular exam. Remember, it was example of school grades. One teacher noting down in the traditional way, noting down all the students' grades, and in case of new way, blockchain way, everybody keeps a private copy of the school grade card for the whole class. So let's take this particular example where Alice had earned 80 points, Bob 92, Carol 76. Our task is to understand how in the blockchain technology these piece of information will be recorded. So block one will contain first student who was Alice in the grade card. So the data for block one will be A equal to 80. Here, since this is the block one, there is no previous block. So the hash of previous block is 00 because this is something called as genesis block or starting block. So what's the concatenated input looking like? It will be just joining of this and making a list. So 80 comes from the data. All these 4 zeros come from the previous block hash. And finally, representation of the block one's information is through this particular hash. And this comes based on the cryptography, right? And as we said earlier, we are not worried right now why hash of this is this. Let's just take it granted, given to us for now. When it comes to block two, we will pick the grade card of second student, right? Or the exam score of second student, which in this case was Bob, and his score was 92. So our block two will be used to note down Bob's score. So data will be B equal to 92. Here, the previous block for block two is going to be block one, and hash of that block will be this, right? We just take this information, flow it over here, and we will have the concatenated input, which is joining of 92 and this hash. And finally, block two's data will be represented as a hash. And let's say this is the hash of block. And in the same way, your block three will have information from the third student, which in our case of the grade card was Carol. So 76 is what we need to include in block three. So that's what is written here. Previous block for block three is block two. And hash of that block was this, and it comes here. Finally, you have the concatenated input 76 and this previous block hash. Finally, you create the hash of block. So clearly here also you see there is chain forming due to this logical connection of every block needing to include previous block's hash, right? So having seen these two examples, we now have fairly decent understanding of blockchain as a concept, the main idea, and also the technology behind it. So that concludes this first section on blockchain. Remember, our goal is to understand PE token, and this is just a stepping stone towards that. So we'll want to take some message out of this section, and that take-home message is really this. So what's the blockchain technology all about? Well, it's a new type of a new type of recording information. And the key thing to highlight here is there is no restriction on the type of information that we can record. So it could be, as we saw in examples, game scorecard. It could be school grades. It could be bank transactions. It could be hospital records. It could be real estate transactions, and anything you think of can be put onto blockchain. And what is the key advantage? These are the advantages. You get a decentralization. There is going to be no single point of failure, right? You get this trustlessness property, because since no single person needs to keep a record of the whole thing, uh, no one has to trust anybody. And these two are coming, temper evident and temper resistant property, because of the need to have a consensus, right? So that concludes the blockchain section. Now, next in the next section, our goal is essentially to understand how this blockchain technology can be leveraged or can be utilized when it comes to finance topics like money, assets, and so on. So let's start with that. So our goal here is first to really understand, since we saw that blockchain is allowing any type of information to be recorded on blockchain, right? So in particular, money, we will see here, is also in some sense type of particular form of information only, and hence there is a clear way of recording money also on blockchain. So let's start. So here we will see in this slide some basics of money. So what is money? Well, it's a bunch of people who have agreed upon something to be treated as medium of exchange or unit of account, right? Medium of exchange, by that we mean if you want to buy something, you give a piece of paper that a group of people have agreed upon, so that once you give that piece of paper, you get that object of your interest, right? That you are willing to get. That's the money. Unit of account, by that we mean you can attach values to things, right? Like a particular packet of breads, right? What's its value? So you can measure it in terms of bunch of US dollars, right? Maybe $2, $3. That's the unit of account aspect of money. What are traditional forms of money? So we know this, right? Printed notes, very well versed with. We are previous in old times. There used to be metal coins, gold, silver used as money. So now let's come to the main real crux of this thing. How we can record possession of money. Well, it's essentially, if you think about it, it's just an ownership claim, right? Person X owns 100 US dollar of money, right? That's what we will say when we want to record information about money related possessions, or when it comes to gold related possession, we will say again through a text that person ABC or A owns 1 pound of gold, right? So this is simply about physical words uh, recording, right? Now, same way in digital setting, when we want to record these things at computers, what we'll do, we'll just insert this text piece, right, in a computer. That's it. So essentially, what we are trying to say out of this is recording of money is no different than recording any other information when it comes to uh, digital computers. Like in digital computers, we record several types of data. Money is also a particular type of data. It's actually just text. And hence, we have this possibility to record money on blockchain also. So, yeah, let's see the traditional way versus blockchain way of recording money in computers. So here, by traditional, we want to emphasize we are not talking about recording money in physical world. Both the things, traditional as well as blockchain, we are talking about digital recording only of money, uh, but two different paradigms altogether. So in traditional setting, we know typically think of a bank has multiple customers, large. So what will bank do to maintain the whole transaction related records? It will have a large database centralized, right? And it will have all the ownership claims of each of its customers. Now, consider a particular example case where there are two people, S, sender, R, the receiver, and they want to do a transaction of $100 from sender S to receiver R. Okay. And before the transaction, let's assume the sender S has $1,000 in her account and receiver R has $500 in her account. So here is how things will happen in the traditional setting. So S will make a transaction request to the central authority, in this case, the bank. Bank will verify whether S has sufficient balance to transfer this $100. Now, in this case, since S's account balance is 1,000, which is greater than $100, definitely the verification will tell the bank that yes, this is possible. So bank will do the following. It will reduce the account balance of S by $100 and increase the balance of R by $100. And this will all be done in a centralized way, since there is just one single large database kept by the bank. And at the end of this transaction, what will happen? The bank would have done a reduction in the account balance for S by $100 to bring it from 1,000 to 900. And the recipient R would have seen his or her account balance getting increased from 500 to 600. Essentially, at both conceptual as well as technological level, that is how, in the traditional finance, a typical bank, which is a central authority, will record information about transactions occurring among multiple customers. Now, let's go back to blockchain way of recording information and exactly see how this whole transaction that we just now saw with the centralized case will occur in the decentralized setting. So remember, we have two people, person S, person R, sender receivers. They want to have a transaction of $100. S sending $100 to R, right? So in the blockchain way, as we saw earlier, there is no single central authority, and every person keeps a shared copy, right? So the ledger of transaction will be available both to S, to R, as well as everyone else in the network. And same as earlier, let's assume both S and R have respectively $1,000 and $500 of their account balances before transaction. So how will this work? Since there is no central authority, right? You may ask, okay, how will this thing automatically get done? So the answer to that is something called as special tools. So for now, let's take this as given. What these tools are, we are going to see in the very next slide. But for now, just assume that there are some special tools on blockchain which will automatically allow this transaction to take place. Okay. And remember, we saw blockchain is a chain of blocks. For every new record, there is new block getting added, hash mechanism being implemented, and logical connection across blocks being developed. So all of that will also happen by using these special tools, which we'll just now see in a very short while. So those special tools are basically being used to invoke this transaction. And once this thing is executed, all the users in the network, sender, the receiver, and everyone else will update their respective copies of the database. And remember, there is this consensus enforcement for this new way of blockchain technology, that every user in the network has to have same copy of the record as everyone else in order for transaction recording to proceed further. So that will be also ensured by this special tools. Okay. So now we have now really created a lot of anticipation about what the special tools are. Definitely we'll see it in the next slide what they are all about. And just to complete things here, these special tools will also finally ensure transaction is safely taking place and account balance of sender becomes 900, receiver becomes 600 after this transaction. So let's come to the main question, what those tools are, right? That automatically do all of these things. So they are nothing but computer programs, okay? So we just now saw that in the blockchain section that essentially any information can be put on blockchain. So computer programs at an abstract level is also piece of information only. So that can also be put on the blockchain. Uh, in the next slide, let's see what this computer program in depth, what they are really, so that we can get a really good grip of how this money related information can be put on the blockchain. That is very critical to understand this aspect here to really get a good idea of how things are happening in this DeFi world. So, what's a computer program? Well, it's just a sequence of instructions. That's it. Like you have a recipe, right? In case of cooking, let's say you want to make some dish or dish one. There will be step one, take this much sugar. Step two, take this much milk, and step three, step four, whatnot, right? Same way, computer program is just sequence of instruction. That's it. Typically, they are text file. They they live on computer memory, and so in case of cooking, the recipe tells you how to prepare a dish, right? Similarly, this instructions in case of computer program, they will tell you or they will tell the computer uh, what things to do. So what are possible things that to be done on computer? So a typical instruction will be go to this particular memory location, retrieve the data from there. Okay, that could be a particular instruction. Another type of instruction would be pick data located at so and so memory address, check if the retrieved data satisfies certain conditions or not. That could be another type of instruction. Yet another type of instruction would be once you retrieve data from certain memory address, replace that memory addresses information by data taken from some other memory location. So these are the at the computer level, these are the kind of instructions that are given to computer through computer programs. Okay. So let's ask. Okay, in since we want to understand, remember, in case of money or finance, how this computer programs or how this computer tools that we saw previously will actually do those transactions, right? So essentially, there will be instructions given to computer in the following form. So first, what type of information will be? Please transfer ownership of this digital asset in from person A to person B. Another type of instruction will be please exchange funds of so and so digital money between these two network users, like that. Or maybe another type of instruction would be carry out auction of this digital assets among these set of network users. Okay, that could be another type of instruction. Yeah, essentially all of this instruction in our human language appears fairly high level. Computer operates at a very low level of information. It's all about zeros and one in the computer. So what will happen is these high level of information through special tools that are well understood in computer technology, this high level of information will be translated into very low level of bits and pieces in zeros and ones language that the computer can understand. Okay. And all of these high level transactions or instructions will be actually carried out through computer. Okay. So that is the power of the special tools that we looked at. So let's go back to that thing where we mysteriously talked about this special tools. So we will replace those tools now with what we understood as computer programs, right? So let's look at whole thing, right? That particular transaction on blockchain. How will that occur now that we have clearly understood what computer programs are? So remember, there is a sender, there is a receiver, $1,000 account balance for sender before transaction, $500 for receiver before transaction, $100 needs to be transferred from S to R. That's the idea. What will happen is sender will invoke this special computer program. Basically, there is a way to make call. So if you're familiar with smartphones, right? Smartphone is essentially also a computer, or let's say even in a computer, you press buttons, right? Or in smartphone, you have touch screen, right? What that aspect or what that touch is essentially calling a computer program at underneath the whole operating system. Okay. Similarly, there will be some buttons developed on this blockchain system, and pressing on that button, sender S will basically make a call to computer program, and that computer program will carry out the instructions that is given, or whatever instruction has been built into in its logic. Okay, so that will be about transaction. And remember, this is blockchain setting. So these tools also need to be smart enough to do that block addition, also doing the hashing work, right? All of that will also be done through the special tools, computer programs. Okay. And everybody in the network, all the users will be essentially updating their network related information after this transaction, right? And of course, there will be this additional aspect of consensus enforcement that will also take place. And eventually, at the end of all of this, finally, the account balance of S will become $900 and that of R will be $600. So that's the real detail of how money related information will be stored in a blockchain setting. This is a very crucial part of the lecture. If you have some misunderstanding, just go back and you can revise this particular piece because it is very critical to really reinforce the whole idea of how money works in blockchain setting. Okay. So having developed this base, now we can go to real life examples of money on blockchain, and let's give formal names to things. So it's called cryptocurrency when there is any form of money created on blockchain. Okay. So we have famous examples of cryptocurrencies. Bitcoin, first ever cryptocurrency. So the network in case of Bitcoin is called Bitcoin network, the blockchain network. And the computer program is called Bitcoin script. Yeah. These are just special names for each of the cryptocurrency. Essentially, all of them have certain special properties for each network, of course, but at a high level, conceptual level, essentially all of them are doing this instruction implementation. That's all. Then we have Ether. The blockchain network of Ether is called Ethereum. The corresponding computer program called smart contract. This is a big buzzword in DeFi space, right? Smart contract, everything works on smart contract, but now we don't have on our mind it's not a it's not a mysterious thing, right? Because we understand it. It's just a computer program, sequence of instructions. That's it. Then we have Solana, another big cryptocurrency. Solana network is the blockchain network for Solana, and the computer program is called Solana program. There are many, many, many cryptocurrencies, right? So having understood now money on blockchain, let's go to how other assets can be put on the blockchain setting. And in course of doing so, we will come across this term crypto tokens. That's again a big buzzword in DeFi space. We will get a good clear understanding about it. So let's come to here also. Our main target essentially is to really understand if we want to put this asset related information on blockchain, how will that happen conceptually and technologically? Okay. So let's start with what are real world assets other than money. So we know real estate, gold, silver, artwork. These are the real world assets on top of money, right? Other than money. So similarly, the assets which are on blockchain in digital framework other than money, which means other than cryptocurrencies, they are called crypto tokens. This is the name. So in our mind, very clear. When it comes to tokens, it's just digital assets put on blockchain. There should not be any confusion about it because there are so many buzzwords running around, and it's very easy to get confused between what is cryptocurrency, what is crypto tokens, this is that, that is this. It's all messy thing if we fundamentally don't understand, right? So yeah, that's the nomenclature of crypto tokens. We have several types of tokens. Uh, so one type is called non-fungible tokens. So for example, art, collectibles, examples, CryptoPunk, very famous NFT. The App Club, again, very famous one. That's one category of tokens. Another category of tokens called utility tokens. So here, these tokens essentially provide access to certain product and services in blockchain ecosystem. So for example, Golem is a utility token, basic attention token like BAT, etc. And there is several other types of token, but the key focus of our talk is going to be governance token. Okay. Essentially, they are the tokens, and tokens in our mind is the digital assets, right? Just on blockchain, assets on blockchain. That's it. So governance tokens are essentially tokens that grant voting rights. Okay. We will see where is this voting right and all of that come from. But for now, let's just take it something given to us. Okay. Yeah. So just to reiterate here too, the basic idea of representing all these digital assets other than cryptocurrency on blockchain is very much similar to what we saw for cryptocurrency, right? You have this special tools, computer programs doing all of this work automatically, and all the consensus mechanism on top of that, network, everybody operating their blockchain and all of those things. Okay. Just like it's there for the cryptocurrency, it's similar things will be there for crypto tokens. Special programs for each token. Okay. Uh, and all of the standard financial activities like ownership transfer, fund transfer, uh, would be carried out by these special tools. Okay. So that's just a reiteration of money on assets, money on digital blockchain setting. So now with that getting completed, let's go to the real thing, the main thing of this lecture. Finally, the governance tokens and VE tokens. That's the thing we want to understand. It's just a special type of governance tokens. So let's motivate what this thing is all about. Okay, governance tokens. So here is the example. You imagine a club where there are a bunch of friends, and in the club there are several decisions to make, like which games to play or where to meet, the what to eat and what those kind of things. And this special club is such that no single person will take any decision. Okay, it will be always this group collectively taking any decision. And let's say everyone gets a special coin here, okay, called governance token. So for now, let's just take that name as given thing, and we'll see why this name is actually intuitive. And what this special coin is going to allow is it will give each member the voting right related to club's decision. So if I have one token, I get one vote worth of right. Okay. Someone has two tokens, that person will have 2 units of vote out. to him or her. And all this votes, what they do essentially, they are going to allow the whole club to carry out various activities and ensure while doing all these activities that the decision making is fair, democratic, right? Because it's happening among a group of people instead of just one person doing. So, having understood that example, here is the formal definition of governance tokens. So, tokens that grant the owner voting rights, okay, on upgrade and future changes in the DeFi protocol. Such tokens are called governance tokens. Now, I agree, we have not looked at what is DeFi protocol yet. So, yeah, next we will understand what that means. So, essentially, DeFi protocol, they are just collection of those special computer programs, okay, which we saw just now. They are just instructions given to compute smart contracts in case of Ethereum network. So, DeFi protocol is essentially a bunch of those programs clubbed together in such a way that they finally allow certain types of financial activities being carried out. Okay. So, for example, a particular DeFi protocol will work like a bank. Another DeFi protocol will be working like a stock exchange. Okay. And all of these things will be done by those special tools. For each of the protocol, there will be a bunch of special tools, computer programs written to carry out those transactions and all the activities, recording information about that specific financial service and whatnot. So that's what DeFi protocol is all about. It's like a specific financial service created on blockchain by using this special tools called computer programs. Okay. So that's what next slide is talking about. DeFi protocol through various examples. For example, uh, a DeFi protocol could be a decentralized exchange itself. Whole exchange can be called DeFi protocol. And we have real life example like Uniswap, SushiSwap, Curve Finance. Then we have decentralized lending platform. They are a type of DeFi protocol called Aave compound in real world, right? And another type of protocol could be a payment protocol like Flexa, XDAI, and so on. And just to go back, we saw governance tokens are essentially tokens that give you voting rights, right? Of related to decisions that happen on DeFi protocol. So what is a DeFi protocol? We saw in financial terms, a bank could be DeFi protocol, an exchange could be DeFi protocol, a payment protocol, a payment service could be a DeFi protocol. Now, you would agree that in each of these services, exchange, payment service, or bank, there needs to be some decision making to be done, right? In order for the whole community of users involved with a bank or whole community of users involved with an exchange to uh, maybe proceed or progress further. Yeah, and that is what essentially voting right is all about, to enable the whole organization of people who have come together to take decisions about what kind of activities to do to make progress. So here is the real life example of governance tokens. So Compound, Aave, Maker, Uniswap, Synthetics, Curve DAO token, Yearn Finance. Yeah. Each of this token, it will essentially give the voting right in the corresponding DeFi protocol. And voting right, as we saw, will be related to what kind of activities are going to be carried out on each of the financial platform. Now, there are certain drawbacks. So, what this slide is telling us is a list of drawbacks that are associated with this governance tokens or this specific model of governance tokens that we just now saw. So, first drawback could be the governance capture. What that means is let's say one of the network user is having a large number of governance tokens for a particular protocol. Okay, what will happen? Because the voting right is proportional to the amount of token, the largest vote share will be available to that particular person, and there is a risk of uh, a high contribution coming in the whole decision making from just one player. And if you think of extreme case, this can go to more towards the centralized system, which basically we want to avoid, right? Whole idea behind this blockchain is to encourage this decentralized way of operating in finance. So definitely this is a big threat. Next would be that there is no incentive in this setting for long-term participation, right? Because there is no restriction on this protocol tokens transferring. Okay, so let's say one person is currently holding 20% of the whole tokens in circulation, and he or she has this short-term trader type of mindset. And what that will do is the voting right will be heavily affected by this one person's constant trading activity, right? And as a result, the whole ecosystem's long term progress will be inhibited due to this kind of short termish players having large contribution in the voting system. And this is the drawback, one of the drawback of uh, the standard model of governance token. And another one would be voter apathy. What that means is that some of the players won't be interested at all in this voting related to organization, right? And if that happens with many individual network users, what will happen is there will be just a small group of people driving the whole decision making process. And there are many such drawbacks, but these were the main three to focus on. Uh, the idea is that the VE token that we are going to see next and the main topic of this talk are essentially designed to alleviate some of these drawbacks. So let's go to the main topic of the talk. So here comes the VE token. Let's look at the main idea. What is VE token? Well, it's just a special type of governance token. And token, what is token? We understood it's just an asset put on the blockchain, right? And we by now have very clear understanding how any asset or money is put on the blockchain technologically as well as we understand it conceptually. So we understand now all the terminology, and hence it will be very easy to really digest what this thing is all about. So let's start with example, as we do with all the things, new things that come up to us. So imagine your favorite candy store, let's say, right, offering special club membership cards. And there is a catch here that if you want to get this card, you need to not only buy a lot of candies, but you need to store some of those candies or large percentage of those candies with the store locker. Okay? You are not allowed to eat them. You have to buy them, but you're not allowed to eat them. Okay. And the condition here is that the longer you agree to keep the bought candies in store locker, the larger your rewards on the membership card will be. Okay, so this membership card is what is the real incentive here. And this extra condition that you need to lock your membership or lock your bought candies in exchange of this membership card is what creates this long-term incentive here. Let's see this example more in detail. So what this card is going to give you is voting rights, okay, to decide what new candies or which new candies can store be buying. Okay. So what essentially this gives you is, if you lock a lot of your candies, you have larger say in future candies and their flavors. So if you like certain type of candies, you can influence the whole network or whole candy stores decision, because you have locked a lot of candies. You have given up your candies, but in return, what you have gotten is this special membership card, and with it, this larger say in the whole decision making process. And also, of course, this membership card gives you some additional rewards in the form of free candies on a regular basis. Okay. And essentially, there is one more aspect to this, that you are showing some form of loyalty towards the candy store, right? Uh, because you are thinking that this store is very good, the management is good, going to last for a long time. That's why you are encouraged to uh, lock your candies for a long time. So with that example in mind, let's map it to the DeFi setting. Okay. So in the candy example, we had candy store, and you need to lock your candies for certain period of time to get the membership card. In DeFi setting, in place of candy store, you have DeFi protocol, a financial system, remember, bank, exchange, etc. And in place of special membership card, you here have the VE token. So VE token is like your special membership card. That VE token gives you so many rewards. Like in case of candy store, it used to give you free candies and regular interval. In case of VE token, it is going to give you, of course, voting right. And in addition, extra financial benefits. You will get percentage of protocols revenue also on a regular basis to your account. Yes, and also extra we will see, yes, there are other additional monetary rewards that you will also achieve. Okay, so that's the whole concept of this VE tokens. So VE token, let's look at, as we do in all the case. First, we look at conceptually what it is through example. Then we look at the actual technology setting, what it looks like. So let's go to the technology part of VE tokens. So just to clarify, VE token stands for vote escrow token. Vote, we know it gives you voting right. Escrowed means locked, right? They are locked tokens. You will not be able to use them for certain period of time. And in exchange, what you receive is the membership card in case of candy store. And in case of DeFi setting, you will get the V token and, of course, voting right, financial rewards, and so on. So this is what this slide is explaining. Basically, you need to lock your native tokens for a specified time period. So in case of, let's say, Curve Finance, the native token is CRV. You need to lock that, and you will get in return VECRV. In case of Convex Finance, you lock CVX, and in return, you will get VECVX. Okay. And for locking how many CRV you get, how many VCRV back, that exchange rate depends on each DeFi protocol. So every protocol will have its own exchange rate. And key thing here is, longer the locking period, better the rewards. Because the main motivation behind coming up with this vote escrow token concept was to align each network user's personal interest with that of the organizational interest. And by doing this time dependent locking, you are encouraging each user to be aligning his or her personal objective with that of the organization objective. That's the idea. And yeah, just now coming to the real life examples of the VE tokens. So yeah, as we spoke, VECRV from Curve Finance, Vote Escrow token CVX from Convex Finance, Vote Escrow BL from Balancer, and so on. Yeah, so those were the real life examples. Finally, coming to the benefits, we already saw through the Candy Store exam. We get increased voting power in the governance decision, definitely. This is a special type of governance tokens, and every governance token has this element associated with it. And on top of that, you will also have additional rewards because you've locked the native tokens. You will have a share of protocol revenue. So remember, like if it is an exchange, there will be exchange fees, right? That will be collected from every user who uses that exchange for the cryptocurrency trading. And as a V token holder, you will on a regular basis receive a share of those kind of fees. And also you will get some benefits like fee reduction. So you yourself will be paying lesser amount of maybe uh, fees for, let's say, exchange or some bank, decentralized bank, right? And yeah, you will also get enhanced yield farming rewards for the locked tokens and so on. There are several other benefits, but these are the key benefits for the investor's perspective. Okay. So that's the whole thing about V token and their benefits. Yes, this is where we will conclude this talk. Just to recap, uh, we understood. So the goal was to understand V tokens, right, and their benefits. So we started off with saying, okay, V token, it has something to do with blockchain. We deep dive deep into blockchain, the main idea, the technological adoption, implementation of it, and we looked at several examples. Then we realized blockchain is essentially a new way, new technology of recording information in a decentralized way. And having understood that idea, we started looking at how we can put money assets on blockchain. And once we develop that understanding, we have clear idea of what is cryptocurrency, what is crypto token, what is the difference between the two, how this whole financial activity can take place in a blockchain setting. We understood it in depth through examples of computer program, what they do, and etc. etc. Having understood all those things, we very now clearly have idea about V token. It's a special type of governance token, and it has several advantages, as we saw. So thank you very much for the talk. It was a long one, but I hope for someone who did not have any background in blockchain, this was really useful, and it would have clarified a lot of uh, confusion. And hopefully, we'll see next time come up with another DeFi concept and demystify that. Thank you very much.